Greetings, my fellow humanoid dwellers. I create videos on technology and other random things. If you like this video, you might like others. If you don't like this video, you still might like others. Consider subscribing to my channel or checking out my Patreon page. If you already subscribe, hit that bell. Okay, in this video we're going to pick up from where we left off. I've added a meter into the circuit, so now the path is across this bar, through the meter, down through the resistor, across this, through the capacitor, and to ground. The meter is set up to measure current, and if you remember right, current has to be measured in series. This one is still set to measure voltage, which will measure the voltage across the capacitor. If you remember, we left this with a 500 ohm resistor and a 100 millifarad capacitor. I'm going to decrease the capacitance because if you remember, decreasing capacitance will make it charge a little quicker, and that'll help speed up the waiting. We're going to make it a 10 millifarad capacitor instead. Now by measuring current along with resistance, you can see as the voltage is going up across the capacitor, the current is going down, which makes sense because as the voltage goes up across the capacitor, the voltage across the resistor is going down, and we calculate current by taking voltage and dividing it by the resistance. So as the voltage goes down, the current's going to go down. And as the current goes down, it will charge the capacitor slower. It would be like a water stream going down and down, filling a pool. It would take longer to fill up with less current. So it should make sense that as the capacitor takes more of the voltage, the current will go down and it will take longer to charge the capacitor. Anyway, and you can see that it will fully charge. So I'm going to stop it now. And I'm going to do something crazy here and add another resistor, and it's connected on this side of the capacitor, and it's connected to this side of the capacitor. So it's in parallel to the capacitor. If you remember from our resistor tutorial, in parallel, if one resistor is 10 times larger than the other resistor, you pretty much just take the value of the smaller of the resistor. When you first start up a circuit with a capacitor in it, the resistance of the capacitor is essentially 0. So when we start up this circuit, it's going to be pretty much the 500 ohm resistor and this capacitor, because you can ignore this because 0 resistance is way less than 10 times lower than 500 ohms. But then as the capacitor charges, it reaches a point of having infinite resistance. At that point, the circuit will be 500 ohms because infinite is well over 10 times larger than 500 ohms. When we start the circuit up, it will have 500 ohms here and 0 ohms down here. So the full 9 volts will still be across this. As the capacitor charges, the resistance of the capacitor goes up to infinite resistance. So as it reaches infinite, we know that infinite is well more than 10 times 500 ohms. So once this balances out, it will be 500 ohms and 500 ohms. So the voltage will split between these two resistance. So this will start at 9 volts and will end up at 4.5 volts. We'll start it and you'll see. You can see the current still decreases and the voltage still increases. And you'll see that it will level out at about 4.5 volts. The key thing I want you to get from this video is when you start up a circuit, a capacitor has essentially 0 resistance. As it takes a charge, the resistance goes up and the current flow through it goes down. So it essentially will be 0 and all the current will go through this resistor instead of this capacitor. And that's about it for this video. Thanks for watching.